Hi, and welcome to the first ever Rings of Saturn YouTube tutorial. I'm Andrew Weiler. So this is a cool little effect that I've been experimenting with. Sort of a different approach to classic dissolving and melting in that we'll be using rigid bodies. We'll start by setting up a process to scale down packed RBD objects at the pre-solve stage of the sim, and then we'll break their corresponding constraints. Then in the next video, we'll take it a little further and source flip fluids from the inside faces, and we'll mesh it all together. I will say, this being Houdini, there's probably many ways to approach an effect like this, but after a little bit of experimentation and research, this is what I was able to come up with. So as always, if you have any input or feedback, and especially if something is unclear, please just let me know. Okay, so let's get started by setting up some source geometry, and for this, we'll keep it real simple and use the included template head. A couple things we need to do to prep this. Let's first of all clip it at the base. Maybe 0.095 seemed to work for me. Let's see. Looks good. Let's also polyfill that because we'll need watertight geometry. Scale it up a little bit by about 5. And last of all, match size and justify it to the min Y so it's resting on the ground plane. And let's rename this Geo Source, and we're ready for next steps. Let's drop down another geo. We'll call this RBD Sim. I like to color the sim geos yellow just for ease of reference. Let's copy this. Control C. Object merge. Control V. And let's drop down an RBD material fracture. Before connecting it, let's change a few things. Let's get rid of the secondary fracture. Let's not use any noise. Maybe 500 points. And in the constraints, let's set this to -1. That means glue constraints will be unbreakable. We're going to do all that manually. All right, so connect. Yeah, looks good. So next we need to set up a growth solver in order to trigger our rigid bodies. And what we're going to do is we're going to have it start at the base here and just start moving upward and trigger all the rigid bodies. And there's many different ways you can do growth solvers. We're going to keep it simple and just use the Pyro source spread. So, points from volume. Set it to 0.015 and be sure to jitter it. Next, we'll group just the points at the base. Set this to points and group by bounding regions. So this will be our start area right here at the bottom. That's about right. And let's call this start. We'll also need a temperature attribute. So create attribute. This will have a value of 1, but just for the start group. Next, let's drop down the Pyro source spread. And you can see if we visualize total burn, and that's the attribute that we want to use, something's going on here at the base where our temperature is set to 1. And it is spreading, but not fast enough. So let's adjust a few parameters. First off, let's drop the cooling rate down to maybe 0.2. And we want a little bit of noise, but the element size needs to be a little smaller. And let's make our rate maybe start with 4. All right. So that's pretty good. Set our timeline to 72. That's about right. Let's maybe make it a little bit faster. And that looks pretty good. Let's go with that for now. We can always come back and adjust it. So the attribute we need is that total burn. So if we look in the spreadsheet here, it's starting at 0 and it's incrementing. We're just going to keep it real simple right now, and we're going to rename that attribute to my age. So if we look here, my age, and we'll also get rid of all the attributes we don't need. So the only thing we need from here is my age, delete non-selected. All right, now let's preview this and see how it's working. Get the output from our fracture, and we'll transfer my age to that. Let's color it the ramp from attribute, and that attribute will be my age. And there we are. Actually, we need to go ahead and pack our widgets before transferring the age attribute. So let's drop down and assemble. Create packed primitives, and let's turn off create name attribute. We're going to let the material fracture do that for us. All right, so in order to preview that, we need to unpack and transfer my age. All right, so this is what's happening in the solver. Now let's add a few nulls for easy reference. We'll put one right here. Call this growth preview, and we'll branch one out from right here. This is what we'll reference in the RBD sim. So we'll call this growth out. Next, put down a DOPNet. And let's start setting up our RBD sim. So we have a pretty standard rigid body setup here. Actually, I don't think we need this static solver. We'll get rid of that. Let's do a couple things. First of all, let's not display the ground plane. And let's wire our packed objects into input 1 and constraints into input 2. So reference that here. Geometry source, first context, and in the constraint network, let's grab the constraints from the second context. Let's also copy and paste the rigid object and make sure that's the only thing we're exporting here. So we don't need the ground plane. If I press play right now, you'll see nothing's happening. And the reason for that is because our glue constraints are holding everything together. So if I turn this off, no constraints, it'll just fall into a big heap. Now here's where we get into the fun part. Let's talk about next steps real quick. So we have our myAge attribute that we're creating with this growth solver here. We need to import that attribute into our DOP.NET and use it to adjust p-scale on our packed RBDs at every time step. So if we visualize that, let's do visualize attribute. myAge, make this a marker, and make it a large size. We can see it's incrementing from 0 across all of our packed prims up to, it looks like, about 36. So that's an arbitrary range right now. We'll remap that to something that suits us once we get into this a little bit further. We'll need a few more things in our DOP.NET here. So let's add 2 SOP solvers. One connected to our rigid post solve, and one will connect to our constraint solver. We also need a geometry wrangle, and that'll go into the pre-solve. Let's also make sure the second input of that wrangle is pointing to the second context geometry, and that's our constraint input. Let's rename these. This geometry wrangle we'll call update p-scale. This SOP solver, let's call it import myAge. And this one, break constraints. Now we need to grab our myAge attribute from our SOP level prims here and import them onto the corresponding DOP objects in the simulation. And we can do that because they have matching name attributes, since they're all being created by this material fracture upstream. So let's get to it. First off, let's Control-C here and get a path to this null. And we'll dive inside of our import myAge SOP solver and add a few things. Attribute wrangle, and object merge. We're going to paste the path to our growth out null, wire that into the second input, and DOP geometry comes into the first. We're going to use a vex function called findAttribVal in order to do the matching by name attribute. So let's create an integer variable. We'll just call it match, and that's going to be equal to findAttribVal. Get the second input, so data from our growth out. The data type is on points because they're packed prims. The name, attribute name, is name, and the value is a string value name. Now, we're going to say myAge is equal to myAge coming in from that second input. Using that match integer to make sure we get it onto the corresponding DOP object. And that's that. And now that we have myAge coming into our DOP.NET, we can do a few things here in this geometry wrangle. So Let's set up an integer variable. We'll call it point count or PNT, CNT. And this will be using the endpoints function, finding the number of points from our second input. Let's also add a float variable called age inc, and we'll initialize that to 0. And then we just need a quick little for loop. We want to loop over all of our points. Now remember, these are packed prims, so essentially they're points. So what we're doing here is, for each of our incoming points, we're going to take my age from a value of 1 to a value we're going to set called age max. Let's just set this to 36 for now. And we're fitting that from 1 to 0, because remember, we're scaling down our p-scale attribute. So next, let's do that. Let's say at p-scale. Let's multiply that by this new value. Let's check to make sure this is all working for us. First of all, we will need to initialize our p-scale. So let's create an attribute. And we'll initialize that to 1. And for now, let's turn off this SOP solver here. And let's also set our glue strength to -1, which means unbreakable. So if we run our sim, as you can see, RBD objects are scaling based on the incoming myAge attribute. All good. You'll also notice that the constraints are not breaking, and that's what we'll do next. So let's dive inside this SOP solver and get things set up. We'll need relationship geometry and DOP geometry. Now, relationship geometry in this case is going to be our constraints. Let's also make sure we're referencing the right DOP object. Copy, paste that, and just replace this. Let's also grab the wrangle we set up in this other SOP solver. Paste that in. We'll have relationship geometry coming into the first input and DOP geometry into the second. I'll make a few changes to this wrangle. We don't need myAge. Let's grab p-scale instead. And I also need to promote that p-scale attribute to a primitive, since we'll be working with constraints. Last of all, let's set up a rule to break those constraints. Another attribute wrangle, this time running over primitives. And we'll say if p-scale is less than 1, let's remove that prim. Should be it. Let's just verify here that our glue constraints are set to -1. They are. Strength. And let's give it a go. And there you have it. You got this cool sort of eroding, dissolving effect. Let's do something a little different. Let's put our start point, our start area somewhere else. Let's see here. All right, let's run the sim. And then we have a little kind of imploding effect. So it's a lot of fun. There's a lot of things you can try out with it. That's the end of this segment of the course. In the next one, we'll get into sourcing flip or pyro from the inside faces using the debris source sump. So hope to see you soon.